How you doing, everybody? It's MrDoTheMath here, and today I want to talk to you guys about transformations, but not just any type of transformation, reflections, right? Reflections is when something is turned around about an axis, right? If you look at a mirror, your reflection is basically, your reflection is an example of you being in the exact same place on the other side of the mirror, hypothetically speaking, right? The same rule applies to figures along an axis on a coordinate plane, right? So what happens then is this: a reflection is basically when a figure, when you have an isometry, a figure that is on the exact same place, or the opposite place of the line of reflection. The line of reflection would be referred to as the mirror, right? It would be the mirror line. All right. So if, for instance, I have let's do it this way. Let's create a it's like coordinate plane, right? So here we go. Okay. So this is 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. All right. So we have a coordinate plane here, and if I said that point A, let's say point A is here. Point A, which is located at 3, -3, is reflected along the, let's say it's reflected along the y-axis at 1. All right, so this is line N. So 3 is going to be reflected along the y-axis at 1. Its reflection, this will be known as the line of reflection. This is the line of reflection, right? Reflection. Let's make this an R. Line of reflection. Line of reflection. To figure out where the A's new place, or the A reflection is, we would count how far away this point is from the line of reflection, and then his mirror image, or the new image, would be the exact same distance on the opposite side of this line of reflection. So if this is at -3 on the y, and we got to go up to 1, that's going to be 1, 2, 3, 4 places away from the line of reflection. So we got to go 4 places up. So that'll be 1, 2, 3, 4, right? So A prime would be at 3, because the x didn't change, the y changes. 3, 5, right? 3, 5. Okay, that's pretty much it, right? So let's look at an example. So to find the line of reflection, you plot the image, right? This is the pre-image. This is the image, right? 5 is 4 spaces away from 1. This is y equals 1. This line here is horizontal line. This is y equals 1. The pre-image's point is at -3, so it's -3 on the y. That's 4 places away from this line of reflection. All right, so then 4 places away above this line of reflection would be 3, 5. All right, that's how you find your line of reflection, right? And so let us look at another example. Let's look at an example where we actually have more points. So let's create a figure here. So if this is the 1 point, this is 3, -3. Let's make B. Let's put B over here at B would be, let's see, -2. B is located at -2, -2, -1, and let's put C. Let's put C down here at -1. This is C at -1, -4, -1, -4, right? So again, the way that you find the reflected, or the images for B and C, you count how far away you are from the line of reflection. Again, the line of reflection is at 1. So if this is at -1, that's 0, 1. We're 2 spaces away from the line of reflection. So from here, we'll go 2 spaces above, 1, 2. So then B prime would be here. B prime will be here at that is -2, 3. Okay, 2 spaces from 1, 2 spaces from 1. 2 spaces from 1 here is -1. 2 spaces from 1 here is 3. And then the same with C. Let's count how many spaces we are from the line of reflection here. That's 1, 2, 3, 4, 5 spaces. So he's 5 spaces away from the line of reflection. So we're going to be 5 spaces in the opposite direction. 1, 2, 3, 4, 5. Bam. So C prime is going to be located at -1, 5 places from 1, which would be 6, right? You also could potentially, so 1, 6. Might just leave it there, okay? -1, 6. So then our original triangle looks like this. Our reflected triangle also looks like that in the opposite direction, all right? So there you have it. And that's along when it's reflected along the y-axis. Now, there are 4 main rules, things to remember when you have reflections, right? And so let's write this down for you. If any point AB is reflected, we'll make this line mean reflected, is reflected at the x-axis, right? If any point AB is reflected on the x-axis, what happens to your image point, so this is pre-image, the image would be, the A would stay the same, or X would stay the same, and B would become negative, right? So if this was 1 and 4, its reflection would be 1, -4. Okay? That's it. Now, if you got AB, any point AB reflected along the y-axis, what would happen to the point is that A then X would become negative, and B would stay the same. So for instance, if this same point, 1, 4, was reflected along the y-axis, its new image would be -1, +4. Okay? You got that? Now let's look at the last two. Okay? The last 2 rules, let's see if I can write it down first. If any point AB is reflected on a specified line, so a slanted line, so a line where y equals x, which means this is a line with the slope of 1, what would happen is B and A would change positions. So they would just flip. These would flip. So again, if this was a point 1, 4, and it was reflected along y equals x, or y equals 1x, the new location of this point would be 4, 1. And then the last one would be if let me see if I can sneak it down here. If any point AB is reflected along y equals -x, right? What would happen is it flips again, it still flips, but both A and B are negative. Therefore, the new point would be -4, -1. Okay? And so these are the basic rules. Let me rewrite them for you so you see it again. Rewrite it. One more time. Any point AB reflected, let's say it's going to be reflected at the y-axis. At the y-axis is -AB. Reflected along the x-axis. I put x-axis first the first time. It'll be just a -B. Reflected along the line y equals x, it would be BA. It flips. And then y equals -x, the negative line, it would be -B, -A. Okay? Again, y-axis, A becomes negative. The x becomes negative. X-axis, the y becomes negative. If it's on a line with a slope of 1, the x and the y flip positions, they change positions. And then if it's a negative line, the x and the y change positions, and they become negative. Okay? And that is how we deal with reflections. So if you can remember these rules, and remember to find your distance from that point to a line of symmetry. Not the line. It would be a line of symmetry. It really is a line of symmetry from the line of reflection. Then you'll have no problem with finding your new image point. All right. Let's do the math out. Please remember to like and subscribe below.